Hey, I'm Arushi Singh and I'm in class 10 and I'm from the Martiniere School, Kolkata. Today I'm going to show you all a simpler way of solving a double cone mensuration sum. So we could start by getting more familiar with our topic for today, mensuration. Mensuration basically is a part of mathematics that focuses on geometric figures and their parameters. For example, area and perimeter are the most common ones, and capacity, volumes, curved surface area, length, and there are many more. Mensuration also makes us keep a constant check on the equations we equate or form and the properties of various geometric figures. So, our object for today's sum is a double cone. A double cone can be made up of two solid cones of the same dimensions joined together by their bases. It's a geometric figure made up of two circular cones placed apex by apex by its little definition as shown. So, before we hop on to the question for today, let me show you all how a double cone object might look when we represent it in a 3D form using set squares. If we look at a set squares and if we place two identical set squares in front of each other as a mirror image, we can see that it will look just like a two-dimensional double cone. When I'm rotating it, you can see that it is somehow creating an image of a double. Our question for today is that a right angle triangle whose sides are 3 cm and 4 cm other than the hypotenuse is made to revolve around its hypotenuse. We are supposed to find the volume and the surface area of a double cone so formed. Now we all know that the hypotenuse is the longest side of a right angle triangle, which is just the opposite side of the 90-degree angle in every right angle triangle. We also will take pi as 3.14 in this sum. Now, looking at the diagram of this right angle triangle, it might look like we have a 90-degree angle already formed in it. We can call the 90-degree angle, say, angle B for our sum. So the opposite longest side is our hypotenuse. Now from the values given to us from the question, we have the following with us. Side 1, which is 3 centimeters, side 2, which is 4 centimeters, an angle that is 90 degree, and the third side which is completely unknown to us, which we are supposed to find out using the Pythagoras theorem. The diagram here shows us that side AB is 4 centimeters. The 90-degree angle has been named as angle B, side BC as 3 centimeters, leaving us with side AC completely unknown to us. Using the Pythagoras theorem, we have found out that our hypotenuse side AC is equal to 5 centimeters, which will be shown now. To find the hypotenuse side, we have to use the Pythagoras theorem. In our previous diagram, we were left with side AC unknown to us, which now we're going to find. The double cone so formed by revolving the right angle triangle ABC about its hypotenuse is shown in the following figure. Now to find side AC, we are going to use the formula. We all know that hypotenuse AC can be found out using the formula root over BC square plus AP square. So when we put the values from the diagram, or rather from the question that we got, we will conclude with root over 3 square plus 4 square. On evaluating the following equation, we come to the conclusion that hypotenuse AC is 5 centimeters. Now, to find the radius of the triangle, we need to find the area of the triangle ABC, which we are going to find by using the formula half into AB into BC. Now we know what AB and BC is, so we're going to put the values and we're going to conclude with half into 4 into 3. An alternative method to do this is if we take the side OB and our hypotenuse BC and do the sum. So we conclude this equation with half into 5 into OB, which is equal to 6. On comparing RHS and LHS, we get OB is equal to 12 by 5, which can be further reduced to 2.4 centimeter, which is our radius for today. Now, in order to find the height of the first cone, we will consider that in triangle AOB, we have angle B is 90 degree. So, the line AO is going to be our height 1. Now, using the Pythagoras theorem, we know AB square is equal to AO square plus OB square. So by putting the values, 4 square is equal to AO square plus 2.4 whole square. Now on further calculation, we come to the point where AO is equal to root over 10.24, which will be further factorized to AO is equal to 3.2. Therefore, AO, which is one of the sides of the triangle AOB, is our height 1. Now to find the height of the second cone, in triangle BOC, we have angle O as 90 degree and the side OC is going to give us our height 2. Using the Pythagoras theorem, put in the formula, we get BC square is equal to OC square plus OB square. On putting the values we have, we conclude to 3 square is equal to OC square plus 2.4 whole square. Now, on further evaluating the following equation, we come to a point where OC square is equal to root 3.24. On evaluating that, we get our height 2 of the cone, which is 1.8 centimeters. Now to find the volume for double cone, we have the following measurements that we have found out in the previous few steps. To find the volume for double cone, the formula is simply just volume of cone 1 adding up to volume of cone 2. So we also take R, the radius, as common for both cones just for the sum. Now using the formula, and putting the values that we already have, that's our the radius, height 1 and height 2, we have to evaluate the equation, which brings us to the answer that's 30.14 centimeter cube. Hence our volume for the sum is 30.14 centimeter cube. So before solving the sum in the question, we just had two sides and one angle given, and all we knew about the diagram was that it was a right angle triangle. Instead, by the end of the sum, we found out that it was a double cone, basically two cones joined together by their bases. So the main motive of the sum was to find the surface area and the volume, which I hope I could show it in a very simple way. And while solving that, we found out more sides, which helped us make it more simple and easy to understand and solve. So that was my video and I hope you liked it. Thank you.